Welcome to this video that's going to have a look at how to solve absolute value equations. And we will do, like we've done with many things so far in this unit, we'll examine both linear versions and quadratic versions. So there's going to be two ways you can do it. One is by graphing, which relies basically on your knowledge of technology rather than your knowledge of mathematics and algebra. So what you can do is if you have, this works for any equation, you kind of use your equal sign as a division of two sides, and you type into some graphing software y equals the left side, and then you type in y equals the right side. So this would be the left side, looks like this, it's this v. The right side, y equals 6, is this horizontal line, and then you look for where the two graphs cross over to each other, and those will give you the x values for your solution. So in this one I can see they crossed once here at -1.5, and then they crossed again over here at 4.5. So the answers to this, based on this technology, graphing software, would be x equals -1.5 and also x equals 4.5. Both of those would be correct solutions. So our probably most efficient way to do that would be using Desmos here. We've used that program a couple of times, so I'll do one later on using this piece of software. But what we're going to be more interested in is teaching you the algebraic approach to do this. So assuming we're back in the days of no cell phones and we don't have the technology that we do now, how would we do this by hand? Well, it kind of models the piecewise strategy. What you must make sure you do is examine the two possibilities. What if between the bars is positive? So you need to figure out what would make that happen. 3 minus 2x greater than or equal to 0. Minus 2x greater than or equal to -3. Divide by -2. Divide by -2. Make sure you reverse this because you're dividing by a negative. So x would have to be some number less than or equal to 3/2. Otherwise, between the bars is not a positive value, and this case doesn't work. So if between the bars is positive, you just get rid of the bars and you solve it like a regular old equation. So it's just this. Now we solve it. That's a basic middle school equation this is. So bring that over here. You get 3. X then would be -3/2, which is less than or equal to 3/2. So I accept that answer. All this is for here is to determine whether you're going to actually accept this answer or call it extraneous. So because it meets this criteria, then we accept that answer. So that's, if you remember, we know this is the same one we just did on the picture back here. So -1.5 was one of the answers. That's what I just got right there. So there's one of the answers algebraically. So the other possibility would say, well, what if between the bars is negative? Well, that can only happen if this expression, 3 minus 2x, was less than 0. And that would only happen if x turned out to be greater than 3/2. So like before, if between here is negative, and I'm going to solve it without those bars on it, I need to take the negative of it to switch it to a positive. So it's going to become -3 plus 2x is equal to 6. 2x is equal to 9. X is equal to 9/2, which is bigger than 3/2, so that answer would also be accepted, and that's 4.5. If you remember back here on our sketch, the other answer was 4.5. So this is using technology. This is using good old-fashioned elbow grease and algebra. Elbow grease is hard work for those that don't understand that analogy. Okay, so let's solve a few of these. Okay, here's an absolute value linear equation. So we look at what if between the bars is positive. So first thing you do is figure out what will make that happen. What will make between the bars bigger than or equal to 0, which is positive. -2x is bigger than or equal to -5. Dividing by -2 again, so you got to reverse the inequality. So less than or equal to 5/2. So I only am going to accept the answer I get here if it is smaller than or equal to 5/2. So if it's positive, you just solve it as it sits and you turn the absolute value bars into regular old-fashioned brackets. And now we just solve this. So 15 minus 6x plus 4 is equal to 9x minus 1. I'm going to bring the minus 9x over to give me minus 15x. This is going to give me 19. When I take it that way, it'll give me negative 19 and that. So negative 20. Divide both sides by negative 15. Reduce this, it would be 4/3. 4/3 is not less, yes it is, sorry. 5 over 2 is 2.5. 4/3 is 1.3 repeating, 1 1/3. So this is less than 5 halves. So I am going to accept that answer. Okay, between the bars might be negative. Now we've done enough of these that you can redo this every time if you want, but the negative is just the opposite of this one. So it's going to be when x is bigger than 5 halves. Don't put the equals sign because I already put it up there. So if x is bigger than 5 halves, you'll get a positive number in there. So if between the bars is a negative value, which is what I'm analyzing now, then I got to make sure I multiply it by a negative 1. So in this one, the easiest way to do that would probably be just stick a negative out in front here, which will then go through the bars. The important thing is that you only put the negative, though, through the bars, not out through to all the other stuff. So this would stay plus 4 equals 9x minus 1. So now I need to solve this equation and see what I get. So negative 15 plus 6x plus 4 equals 9x minus 1. This will give me negative 3x minus 5. That'll give me 10. And I'm going to get here negative 10/3. Now here's an example. So this is, it shows you why this is important. So this looks like it's an answer, negative 10/3. But unfortunately, negative 10/3 is not larger than 5 halves. So negative 10/3 doesn't give us the negative version of this. So I'm going to have to cross that out and call it an extraneous solution. So I only had the one solution, x is equal to 4/3. All right, so let's see if we can get on a roll here. So this one, absolute value, it's telling us already it's going to have an extraneous solution. So let's see how that all plays out. So between the bars, positive. 2x minus 5 is what's between the bars. I need to figure out what's going to make that greater than or equal to 0. That will happen if x is bigger than or equal to 5 halves. So if between the bars is positive, you just write the equation without the bars. And you solve this. Bring that over there, you get 5x. Bring that over there, you get 10. X is equal to 2. There's one answer. Look at the other possibility. So 2x minus 5 could be less than 0. So that's going to be when x is less than 5 halves. The difference is you need to multiply between the bars by a negative. So it's actually going to be negative 2x plus 5 equals 5 minus 3x. Now solve this. So bring that over there, you get x. Bring that over there, you get 0. Unfortunately, actually no, it is. So I never crossed this one. So let's back up a second. So I got 2, but my answer, in order for this to be the positive version, so if you put 2 in there, you'll see 2 times 2 is 4, 4 take away 5, I get a negative 1. It's not between bars positive. So this answer would have to get eliminated. That's extraneous. And the reason I knew that is because it wasn't bigger than or equal to 5 halves. Now this one, 0 is less than 5 halves. I am going to accept that answer. So the only solution is x is equal to 0. This one says it has no solution. Let's have a look and see why that is. Well, I'm going to go between bars positive. So 3x minus 4 greater than or equal to 0. 3x is greater than or equal to 4. X is greater than or equal to 4/3. So if it's positive, you just solve it as if the bars weren't even there. whether we're just regular brackets. So 3x, this will give me 8. This will give me a 1 then when I take that over there, is that right? Plus 8, yep. Divide by 3, I get 1/3. 1/3 is not less than or equal to 4/3. That's extraneous. Between the bars negative. So 3x minus 4 is less than 0. That'll only happen if x is less than 4/3. Now you need the negative version of between the bars. So I took the negative of between the bars. And now solve this version. See what you get. Negative 3x. This will be 16, so I'm going to have to take away 9 minus 16 is going to be negative 7. X would come out to be 7/3. 7/3 is not smaller than 4/3. That one gets thrown out as well. No solution. Just want to show you something. What you could have done here, if in the beginning we had moved this 12 over, 9 take away 12 would have been negative 3. If I had made that little change, I may have been able to save myself a whole bunch of work and say, hey, wait a second, there's no possible way this can happen. I'm going to take the absolute value of some expression over here and it's going to spit out a negative answer. That's not what absolute value does. Absolute value does the exact opposite. It always turns it into a positive. So if you were to happen to have done this first and notice this, do not do all this work. Just look here and say, there's no solution. This is impossible. But unfortunately, we didn't do it that way. But either way, you'll still get the fact that there is no solution. Okay, so let's progress and continue solving absolute value equations, but this time it will be quadratic. It's done nothing any different. Do it the same way. So between the bars is positive. So x squared minus 3x must be bigger than or equal to 0. What is different though, I'm going to run into a quadratic inequality. Now we did these in a couple of the videos prior to this in this section, so we should be getting fairly comfortable with these by now. Find the zeros, so x onto x minus 3 would be the factors of that. Make it equal to 0. The zeros then are x is 0 or x is 3. So 0 would be here, 3 would be here, it would open up. So this would be positive here, so if x was less than or equal to 0, or if I picked an x value over here, x is bigger than or equal to 3. So when I solve this, I only accept answers that meet these intervals. The positive version, you just write it as if the bars aren't there. So let's solve this quadratic. What I love is this makes us go back now and review Unit 1. We have to be able to solve quadratics. Multiply to get negative 2, add to be minus 3. That is not possible. So it won't factor. We need to go quadratic formula. Negative b plus or minus square root b squared, take away 4, multiply by a, multiply by c, all of that divided by twice the a value. Plus or minus, this, so that'll be a plus 8 and 9, that'll give me 17 over 2. So x will equal, grab my calculator, give me a second. Alright, so I had just grabbed my calculator, I did my 2 calculations, so the positive version gave me this. When I subtracted root 17, I got this. So now I got to cross these against these. So is 3.572 either less than or equal to 0 or bigger than or equal to 3? Well, it's bigger than or equal to 3. So this one is good. 0.562 is not bigger than or equal to 3, and it is not less than or equal to 0. Unfortunately, that one is extraneous, so it's gone. So I got that. That's only half, though. I have to check the other possibility. What if between the bars was a negative value? So here's my quadratic that's between the bars. It will be negative if you pick an x value that's down here. So if 0 is less than, or no equal sign, sorry, I already used the equal signs up there. So if x is bigger than 0 but less than 3, that means between 0 and 3, we would accept it because it will make the quadratic have negative values. So now, when I solve, I need to take the negative of between the bars, so it would be negative x squared plus 3x equals 2. Let's move everything to the right so I don't have a negative x squared, so it's x squared, take away 3x plus 2, multiply to get 2, add to give minus 3, that will factor, negative 2 and negative 1, giving me two answers, 2 or positive 1. The number 2 is between 0 and 3. The number 1 is between 0 and 3. We'll take both of those. So what did I get? I got that answer and then both of these. So I ended up with 3 different answers for that one. Now I said at some point that I would do one of these on decimals. Let's do this one. So should be one that I can keep track of. So I'm going to type in, for one of my equations, I'm going to type in the left side, y equals absolute value x squared minus 3x. And then my other equation is going to be y equals the right side, which is 2. Okay, so hopefully I can remember that. I might have to scroll back here. So absolute value, I think I have it ready. So y equals, on a laptop you got to type ABS, that's absolute value. And I believe it was x squared subtract 3x. And so hit enter. My other one was y equals 2. Y equals 2. I should be getting, I know what I think I did. So I should have got that one, 2, 3, 4. So I had this one, I had this one, I had this one. I think I did that calculation wrong. So let's go back here. So here's the beauty of technology. I messed up something. Oh yeah, see, look, I have a positive, that should have been negative. So let me just get rid of so the line should not be through that. It should have been x equals negative 0. I can imagine some of you were yelling at your screen as I had put the wrong answer up there, or you were worried you'd done something wrong. Now that is less than or equal to 0, so I would accept it. So I actually got 1, 2 answers down here. I got 4, which now jives with what Desmos was showing us. So we had 4 answers. So this is a great little program to have to help you solve or check equations that you've solved. And again, it works for any equation. Type in y equals the left side, y equals the right side, look for where they cross. Desmos lets you tap right on those dots where they cross, and it tells you your answers. And we're doing the x's, so x is that, x is that, x is that, x is that. Alrighty, let's look at, I think I'll just do this one. So this is another quadratic one. So let's say between the bars is only positive if x squared minus 3x plus 2 is bigger than or equal to 0. This will factor, so x take away 2 and x take away 1 equals 0. Only if x is 2 or 1. So 1 and 2. It opens up. So it's positive here and here. So it's only positive if you choose x values less than or equal to 1, or you're working with an x value that's bigger than or equal to 2. So when I solve this, my answers must meet this criteria, or we call them extraneous. Okay, so here's the positive version. X squared minus 3x plus 2. So you just leave it like it is. Minus 2x plus 3 equals 0. Now we solve x squared. Take away 5x plus 5 equals 0. That will not factor, so we go quadratic formula. Negative b plus or minus b squared minus 4ac, all divided by twice the a value. X is 5 plus or minus, so this will be 25 minus 20, square root of 5 over 2. X equals, give me a second here, I'll calculate these. Okay, so I just did those calculations. I got these two numbers. Hopefully I did it right this time. So 3.612 is more than or equal to 2, so that one's good. 1.382 is not more than 2, and it's not less than or equal to 1. That one gets thrown out. Okay, between the bars would be negative if this quadratic were down here, and that would only happen if 1 were less than x were less than 2. So I'm only going to accept my answers if they're somewhere between 1 and 2. Because it's the negative version, you must take the negative of what's between the bars. So it's negative x squared plus 3x minus 2. Take away 2x plus 3 equals 0. And now you solve this quadratic, which will be negative x squared plus x plus 1 equals 0. I'm not a fan of a negative x squared, so I'm going to multiply by a negative 1. Unfortunately, it won't factor again, so we're going to have to go to the quadratic formula for a second time. X equals negative b plus or minus b squared. Take away 4 times a times c. All of that divided by twice, not a. A is 1. Right, there's your a. So that's a 1. X will be 1 plus or minus square root of 5 over 2. Alright, so again, I'm going to take a break and get my calculator. Okay, so I'm back. I just calculated those two, and I got these two values again. Hopefully I punched it in properly. So I got 1.618, which is somewhere between 1 and 2. That one's a good answer. I got negative 0.618, which is not somewhere between 1 and 2, so that is extraneous. I throw it away. So I got that answer out of that one, and that answer out of that one. So I ended up with 2 possible solutions for this. So that is how you solve absolute value both linear and quadratic equations. So again, the strategy for both is the same. You examine the positive versions and the negative versions. And I've also shown you how you could use some technology to accomplish the same thing. So if you're sitting there with the technology, you should always be able to check and verify you have the correct solutions. Alright, so now that will end section 4.2C, I believe that one is. And there are some good practice questions in your textbook, and there will be a formative assessment to go along with this. Alright, thanks for watching. Best of luck.